Alright you guys, this is just a really quick video at the end of the night, and I'm going to try to go through it pretty quick. It has been a long day, and I promised you I'd try to get all those rules of logarithms up, and I'm going to see if I can get one more up tonight. Change of base, and I've got the formula right here, and I'm going to try proof it, and then show you how I would use it, and be off for the night. So change of base is basically, if you have a logarithm that has, in this example, log base a of x, you're allowed to change that base, alright, and write it as a quotient of log base bx over log base ba. And it's kind of easy to remember because, you know, we've done a lot of taking logarithms and writing them in separate forms, and this one just puts the x, which is already on the top of the quotient in the numerator, and the a, which is already down below on the bottom, and changes the base. So kind of true to its name. We do a quick proof. Proof is when you take one side, show that it's equal to the other side, without ever having to use the other side within the proof, of course. So we're going to start by taking the left side, log base a of x, and we are going to set it equal. Let me hold on and get a pencil here. Set it equal to y. And then we're going to take it out of logarithmic form by saying, we're going to say a to the y is equal to x. Now, you are allowed to do any operation to an equation, pretty much, as long as you do it to both sides. I mean, we've had tangents and cotangents and arc sine, arc cosine, multiplication, anything. And for instance, an arc sine would take two numbers and turn them into degrees. And as long as that's an applicable operation to both sides would maintain equal. And would continue to be equal. Multiplication does the same thing. I can multiply both sides. They continue to be equal. There are some exceptions. Sometimes we have to use numbers greater than zeros and such. But on that premise, we're allowed to log both sides. So I can take this side and say log. We know most of our logs are base 10 on the calculator we've been using to do this, but we're going to say log base b. Alright, which should be a different log, and that's of a to the y. Now what I've done is I've taken a to the y, and I've turned it into the answer of an exponent. I'm going to do the same thing over here. We're going to go log base b of x. Now we get a power rule for exponents, and the second I put a log on here, log base b of a became an exponent for all practical purposes. Well, this exponent has been raised to another exponent, that y. So anytime I have a power of a power, I'm allowed to multiply it. So I'm going to bring the y out in the front, and that is y times log. I'm having a hard time writing right now. Hold on. Log base b of a equals log base b of x. Now when I isolate for y, we can see that it's multiplied by log base b of a. So I'm going to divide by log base b of a. Come over here, do the same thing. Log base b of a. I'm going to go ahead and bring it all the way up here. Okay. And the left side is now y. That is set equal to log base b of x over log base b of a in this case. We can see that we've actually gone ahead and somehow replicated that entire left side of the equation at this point. Alright, as we can see. And I'm having a little hard time right now finding, there it is. Alright, so this up here, the top, is now recreated on this side, and I can see that this y is left equal to this. So I'm going to go ahead and, at the very beginning we said log base a of x is equal to y, so through simple substitution I can come over here and write that right now. Instead of y, I'm going to substitute back in log base A of x. And we're going to say that is equal to this entire amount, log base B of x, log base B of A. And there's the proof. I'm going to try to finish this up really quick. There's been a few technical difficulties during this. My pen has disappeared once or twice, and I've had a little bit of trouble, but I'm going to show you how to use this change of base really quick. Change of base was created probably well before calculators, because it was really difficult to get the log base of everything. And so we had to do a change of base. So here we go. I'm going to show you what we would use this for. If I had log some other base other than 10, let's do something we're pretty sure about. Log base 3 of 10. And that would equal, I could change that into a base of 10 really easy. Log base 10 of 10 over log base 10 of 3. Now I'm not quite sure what this is, but it is probably something about 2.1. And we would be able to plug this into our scientific calculators, the ones that we possess at school, and you should get 2.1. I have to admit, not a video I'm real proud of, but it's at such a late date that I'm going to let this go as is. And I'm going to sign off. You guys have a good night.